Statistics is the branch of mathematics that focuses on how to collect, organize, analyze, and interpret information from a set of data. Now, data, it can be anything from numbers in context, information that's collected, or even information that's analyzed. There are three ways to collect data. The first way is through the use of surveys. Now, surveys most often involves the use of a questionnaire to measure the characteristics and the attributes of people. So we've completed a couple surveys this school year, but we've all seen a survey. It's just a list of questions that asks you to either pick from answer choices that are provided or to provide an answer to a specific question. So one of the examples of a survey that we have done was when we asked the students what their opinion was about returning to the school during phase 2.5 of COVID-19. It asked questions like, do you want to come back? Would you feel comfortable with the 2-day schedule? Are you a bus rider? Are you a car rider? Are you a driver? Those kinds of questions, just collecting data for a specific reason. Another way to collect data is through something known as observational studies. Now, in observational studies, individuals are observed and certain outcomes are measured, but no attempt is made to affect the outcome. So we see this a lot when working in science experiments. We kind of run this experiment or the situation or the scenario and simply observing the outcome. So an example of this might be a team of zoologists who are watching an endangered species, kind of seeing how it's reacting to nature, seeing how it's adapting, what it's doing to survive, but the zoologists themselves are not interfering with that endangered species or that endangered bird. That might influence or taint, so to say, the data that they're collecting. They're simply just watching and taking notes. So a third type of way to collect data is something known as experiments. Now, experiments are treatments are imposed prior to observation. So experiments are the only way to show like a cause and effect. So it's where you have a situation set up, you have a control group, so something that's not being changed, and then you're assigning certain treatments or certain experiments to a group, a sample of your population, and comparing that to your control group and saying what changed. And again, it's the only way to show cause and effect. So an example of that might be when researchers conduct experiments to test the effectiveness of new kinds of medication. So first they're running, preliminary tests, then the medicine's ready for human trials, and the data is collected and interpreted and analyzed during the human trial phase, and then the experiment is carried out onto groups of volunteers, and then based off of the data they determine if it is going to be an effective or ineffective drug, or who should receive this medication and who should not. And it is a very long and tedious process, but definitely well worth it. So let's look through a couple of examples to see if we can tell the difference between an observational study or an experiment. So each situation you're asking yourself, is this an observed outcome or is this a tested outcome? So 50 people with clinical depression were divided into two groups. Over a 6-month period, one group was given a traditional treatment for depression while the other group was given a new drug. The people were evaluated at the end of the period to determine whether their depression had improved. So is this an observational study or an experiment? So this is an example of an experiment. They went ahead and strategically separated the two groups of individuals. One was giving a traditional medication, which is considered your control group. So this is known, documented outcomes, while the second group was given a new drug and the two results were compared. Let's take a look at our second example. To determine whether apples really do keep the doctor away, 40 patients at a doctor's office were asked to report how often they came to the doctor and the number of apples that they had recently eaten. So is this an observational study or is this a tested experiment? So this example is something we call an observational study because there was not two separate control groups or two separate groups, one being a control group and one having a tested outcome. With this particular example, we were asking patients and simply gathering information or observing information. Our third example says, to determine whether music really helps students' scores on a test, a teacher who taught 2 U.S. history classes plays classical music during testing for one class and then played no music during testing for the other class. Is this an observational study or is this an experiment? So this example is an experiment. The teacher is testing out if there's differences between the two classes based on a specific thing that is being done. In order to collect data for any of these observational studies or experiments, we first must choose a sample or a group of people or objects or animals or whatever that represents the population for your statistical analysis. So there are 5 types of samples that can be collected. So the first type of sample is known as simple random sampling. So in simple random sampling, or SRS, all individuals in the population have the same probability of being selected, and all groups in the sample size have the same probability of being selected. So if we take a look at this example, there are 100 names are put in a hat and 10 are picked. So you have, or this particular name has a 1 in 10 chance of being selected. Well, if we take those same 100 names and we kind of are more strategic with it, and then let's say we place 50 boy names in a hat and 50 girl names in a hat, we want the probability to be exactly the same as when they were just 100 random names and 100 gender specific names. And so in order to keep the 1 to 10 ratio, we would only be able to select 5 boys' names and 5 girls' names in order to keep that probability of being selected as an individual the same as when we put them into groups. The second form of sampling is known as stratified random sampling. So if a researcher wants to highlight a specific subgroup within the population, they divide the population into different subgroups, or what we call strata, based on relevant characteristics, and then randomly select the final subjects proportionally from the different strata. So an example of this might be dividing high school populations into grade level and then selecting from proportional amounts of each class. So we would have freshmen, juniors, seniors, and sophomores. And in order to divide the population and then randomly select in proportionality, let's say we had a specific proportion that we wanted. So let's say 1 in every 10. Well, we would want to apply that same proportion per grade level. Now, data has shown there are probably more freshmen than seniors. And we have, the reason that we have that is, in the course of a high school career, we have people who move or who credit-wise don't have enough credits to be classified as a senior. Maybe they failed too many classes. We have dropout rates. We have early graduation. So there's a lot of things that influence why there might be more freshmen than there are seniors. But let's say we pick probability is, proportionate across the board. So that might be why you might end up with more freshmen selected for this type of sample than you would, let's say, seniors. The third type of sampling is called systemic random sampling. So the researcher selects a number at random, let's say the number n, and then selects every nth individual from a list, chart, or other grouping of uniformed intervals. So it's a little bit like simple random sampling, except that instead of, like 100 names in a hat and just having to pick 10. Let's say that, you have got a list of names and you choose a number at random, let's say 8 or 15. Let's say 15. Then it's every 15th name on that list would be part of your sample, because technically there is a probability of being 1 out of every 15. So the probability of those smaller chunks is exactly the same. Same thing in this example, having all the students line up and then randomly picking a number, let's say 8, every 8 person gets an eraser. So you have the same probability of being selected based on a smaller group of people. So out of every 8 students, 1 out of every 8 is the same proportion or probability, of being selected depending on how many groups of 8 you have. So the probability is still the same. The fourth type is called a cluster sample. So naturally occurring groups of population members are chosen. The population is divided into groups, or what we call clusters, by geography or different kinds of criteria. Then a random sample of these clusters are selected, and all the individuals in the selected cluster are included in the sample. So an example might be taking all of our students and putting them into classes and then randomly choosing a class. So it's a naturally occurring group because that class has already been created. Let's say you're sitting in your science class or your English class. It's a naturally occurring group of individuals, and that the population's divided into these groups. In this case, the group is called a class. The population is the student body, and then randomly selecting a class for whatever is what we call a cluster sample, because the population's already naturally put into these smaller clusters or groups. And the last way of choosing a sample is something known as convenience sampling. This is also probably the most inaccurate, but it is a way of creating a sample based off of your population. It's where subjects are chosen to minimize time, effort, or expenses, and this can be done quickly but can also be biased. So maybe picking the first 100 people to enter the movie on a Friday night. Well, there's no strategy behind that particular group of people. Or, my personal favorite is going to the polling station and someone asking you what your opinion is on voting. Well, that's biased opinion because I'm at a polling station. Of course, I would consider voting to be really important. So you're collecting data from somebody who's already at a place that justifies my opinion. So the data itself is a little skewed or biased or a little misleading or inaccurate. And so this is how companies or businesses might collect data that maybe makes their product or service seem more like reputable than it might actually be. So let's take a look at that term bias. So what is biased? When something is biased, it means that it's leaning towards or favoring one result over another. So if a study is biased, the results are often misleading or they're skewed. So it's choosing who you sample to get the kind of answers or responses or data that you want, rather than what is actually a better, unbiased, realistic representation of a population. So let's take a look at 2 real-world examples of collecting data, maybe interpreting some data, or figuring out what's the best way to actually collect the data samples that we need. So a prom committee is planning the junior-senior prom for this year, and the committee wants to make sure that they honor the preferences of both the juniors and the seniors because it's their prom. So Describe maybe how you would collect the data to answer the question, what type of music is most popular among students at your school? So how would you go about collecting enough data from a sample of your population to get a good feel of what the DJ needs to play at prom? So one individual might suggest maybe a survey or a questionnaire. You could list out a couple genres of music and say, either put these in order and preference. What do you prefer? Or, maybe number your preferences from 1 to 5, with 1 being least and 5 being the greatest. Or select one. And different kinds of ways to collect data, different formats for questioning and surveying. So that's one possible way of gathering the information you need for prom. Describe your plan to then analyze that data. So now that you've got all of these samples, you've got all of these surveys back, how would you begin to organize and analyze that kind of information? So one example might be a bar graph. A bar graph could be used to compare preferences. You could make a table. Could also be created using your favorite music types in class. Maybe your table represents juniors. Maybe your table represents seniors. Maybe you have a two-way frequency table. Maybe you create a pie chart. Maybe you create a dot plot. There's how would you organize your data, and then what kind of information could you glean from that data or analyze from that data, and how will that analyzing influence how you select the music for prom? Let's take a look at another example. An agricultural researcher is investigating the effectiveness of 3 different brands of weed killer. Let's say brands X, Y, and Z. He has set up an area of weeds in a 4x4 zone as shown below. Describe how he could create an experiment to compare the effectiveness of the weed killers. So how could he create an experiment to compare the different kinds of weed killer while still maintaining total randomization and a control group to compare it to? So maybe the researcher could number the zones 1 through 16 and put those numbers in a hat, and then randomly pick out, let's say, 4 zones for brand X, where he just uses just brand X of weed killer on those 4 zones. Maybe he can, if he continues this, then he would have 4 for X, 4 for Y, 4 for Z, and then he would have 4 left over that could be used as a control group. Maybe he sets them up in columns. Maybe the first column is brand X, brand Y, brand Z, and then a control group. Maybe he has them set up in rows. Row 1 is X, row 2 is Y, row 3 is Z, row 4 is your control group. Maybe he kind of keeps them random. Like I said, when you pulled out the numbers, zone 1 is X, zone 2 is control group, and that way he has a very randomized sample. And then the researcher will compare the amount of weed killer in the zones and see how exactly it compares to the other brands, how it compares to a control group, and then he can measure out the effectiveness of that weed killer. So this is an example of collecting data, figuring out, what kind of statistical investigation do I need to have? Do I need to have a survey? Do I need to have simple random sampling? Do I need to have observational data? Do I need to control an experiment? And so it's figuring out what is the best way to collect your data, what is the best way to organize your data, what is the best way to analyze the data that you've collected, and ultimately interpret the results of that data and be able to either make a conclusion or state a conclusion and share those results with other people and use that kind of data or use those statistical data to drive change in the world.